Okay, this what we call as intermolecular bonding. Okay, what is intermolecular bonding? Intermolecular bonding is going to be the bonding between molecule and molecule. Okay, before we actually enter the bonding, I already taught you about, okay, a little bit about what is bonding. We have two types of bonding: intramolecular bonding and intermolecular bonding. So if you have Cl and Cl, okay, the bonding between them, okay, that's going to be covalent bonding. NaCl, then the bonding between them is going to be ionic bonding. Okay, but when it comes to this this kind of bonding, intermolecular bonding is actually between Cl2 with another molecule of Cl2. There will be some sort of bonding. Okay, there will be some sort of bonding. If you have HCl with HCl, of course, I know that the bonding is covalent bonding. But what happens if I have HCl and HCl? What type of bonding that can actually exist between HCl and HCl? Okay, so when we say intermolecular bonding, is the bonding between molecules. Okay, for example, if you have CH4, okay, what is the bonding between CH4 with another CH4? Okay, we will actually identify that. Now, we have, okay, a total of 3 intermolecular bonding that we need to know. Okay, today I will actually teach you about, maybe I'll just teach you about all 3. Okay, no issue, but I will actually go through the last intermolecular bonding separately for the next lesson. But okay, under intermolecular bonding we have, okay, dipole, dipole, okay, dipole, dipole. Okay, it's not the full term. Okay, but I think if you look at your textbook, they have written it as permanent dipole, dipole bonding. Permanent dipole, dipole bonding. So maybe I'll just put permanent. Okay, permanent dipole, dipole bonding. And we also have, okay, hydrogen bonding. And the last one, we have van der Waals bonding. Now, I think since we actually learned about polar molecules and non-polar molecules, I will actually teach you directly about this permanent dipole-dipole bonding. Okay, what is permanent dipole-dipole bonding? Now, if you just look at, okay, the term itself, okay, the term itself, you can actually have, I think, 2 important points that you can come from the term itself. Okay, let's actually see what are the 2 important points that you guys can extract from here. Josh, just looking at the title, what can you actually know about permanent dipole-dipole bonding?
Can't be separated.
What do you mean separated?
Like the bond can't be broken.
Okay. Rather than that, maybe can we comment on this? Is the bonding is permanent. It's not temporary. Okay, the first one, the bonding between this is going to be permanent. It's not temporary. So something that is permanent is going to be difficult to be broken. Okay, like for example, in theory, let's say in theory, there's someone who got married, okay, husband and wife. Can the bonding between them, according to theory, can be broken? Okay, it's quite difficult to be broken. It's considered to be permanent. Yeah, according to theory. Now, what happens if you are having boyfriend and girlfriend? The bonding is still, there is no official binding between them. Okay, you are not officially married. So it's just love. So the love can be broken. Okay, so that is actually temporary. Temporary bonding, they are not strong. Okay, they are not strong. So one thing that I can actually tell you about permanent bonding is going to be a strong bonding. Okay, if you want to actually break them, you need, okay, a lot of energy to break them. Okay, this is chemistry. Yeah, so you need a lot of energy to break them. So that is actually a permanent bonding over there. Okay, permanent dipole-dipole bonding. The second thing that I can notice over here is the bonding between dipole and dipole. Okay, and what is dipole? Sharon, what can you say about dipole? Polar molecules, right?
Yeah.
So it's the bonding between what and what? From the title, you can actually just say, okay, dipole-dipole is going to be the bonding between polar and polar. It means it's the bonding between polar molecules with polar molecules. Okay, one of the examples that I can give you now is going to be HCl. Okay, so Jeffrey, can you tell me whether HCl is polar or non-polar?
Polar.
Polar. Can you tell me which one is delta negative, Cl or H?
Cl.
Okay, this is delta negative, delta positive. Now, imagine I actually put H and Cl. This is going to be delta negative and delta positive. What happens over here is, okay, you will notice, okay, this is going to be positive. This is going to be negative. What can you say about negative and positive? Christopher, do they attract or repel?
They attract each other.
Okay.
So
Opposite charges, they attract. Okay. So it means they start to form bonding. Okay, they start to form bonding. So this is going to be the bonding between the delta negative and the delta positive, or to be exact, if I actually put it here, okay, I can actually just say, okay, it's the bonding between, okay, the hydrogen, okay, it's the bonding between hydrogen and the Cl over here. And this is the bonding that I refer it as dipole-dipole bonding. And this bonding, since the positive and negative is always going to be there, so this one is going to be named as permanent dipole-dipole bonding. Okay, so whenever we try to heat up HCl, okay, when we try to supply heat, okay, do remember, whatever it is, okay, your intramolecular bonding, if you want to actually compare with intermolecular bonding, always remember your intermolecular bonding is considered to be weak compared to intramolecular bonding. It means that if I compare ionic bonding, if I compare covalent bonding, I know covalent bonding is weaker than ionic. Okay, but intermolecular bonding, even though that is permanent over there, I said it's quite strong. Do remember intermolecular bonding is weaker compared to covalent bonding. It means these two, they are still strong. Okay, they are still strong. Okay, compared to the remaining these three. Okay, it means intermolecular bonding, they are definitely going to be weaker. Okay, they are going to be weaker. Okay, imagine like imagine boyfriend and girlfriend. Okay, boyfriend and girlfriend, and then the relationship of them with the other couples in the classroom or something like that. Okay, whatever it is, okay, this bond is much more stronger compared to the other relationship, even though they are kind of always together. Okay, so you do take note, okay, even though the term permanent dipole-dipole is being used over here, when I supply heat, the first bond that will be broken over here will be this particular bond. This particular bond will be broken. Okay, it means, okay, I think a lot of people get confused with this. Like for example, if I have water, okay, let's look at water, HOH, and then you have HOH. Okay, I know this is delta negative, delta negative, delta positive, delta positive, delta positive, delta positive. If I have, okay, intermolecular bonding, the intermolecular bonding will arise from here to here. Okay, delta negative and delta positive. So it means, okay, when I heat up water, okay, when I heat up water, the first thing that I am going to break is this particular bonding. I'm going to actually break this bond, okay, compared to breaking the covalent bond over here. That's why when I heat up water, I'm going to change it from liquid to become H2O gas. You do not get H2O liquid suddenly become H plus O. You won't get that. Okay, so do remember when we boil something, okay, when we say boiling point of a covalent molecule, we are always referring to your intermolecular bonding. Okay, we are always referring to the intermolecular bonding. Very important concept. Okay, so we do not actually try to break the covalent bond. Okay, now we know that, okay, this particular bond is permanent dipole-dipole. Okay, permanent dipole-dipole. Okay, it's between polar molecules and polar molecules. Another example, okay, I know water is a polar molecule and polar molecule. Okay, I give you another one more example, H and F. Okay, delta negative, delta positive, H and F, delta positive, delta negative, the bonding between them. Okay, this one also you can categorize them as permanent dipole-dipole. But we know, that, okay, hydrogen is the weakest electronegativity. Or if you want to change it in the different term, we can say hydrogen is the strongest electropositive. Okay, strongest electropositive, or doesn't matter. In terms of electronegativity, imagine hydrogen is going to get 0% in the mark. Okay, 0%. And in chemistry, we have top performance of the chemistry test, okay, which is going to be 0%, okay, belongs to hydrogen. Considered to be 100%, the top performers there are 3 top performers in chemistry. Who are they? Nitrogen, oxygen, and fluorine. NOF. Now, nitrogen, oxygen, and fluorine, okay, they are considered to be the most electronegative elements in the periodic table. Okay, which one is the most? This one ranking number 1, ranking number 2, ranking number 3. So we select the first 3. Now, any kind of intermolecular bonding involving hydrogen, any combination with hydrogen, with nitrogen, with oxygen, with fluorine, that permanent dipole-dipole must be the most strongest permanent dipole-dipole. So what they did, they have actually given a special name for that bond. Okay, it's still permanent dipole-dipole, but they have actually given a special name. That name is hydrogen bonding. Okay, hydrogen bonding is a special permanent dipole-dipole, and that exists between hydrogen with N, hydrogen with O, hydrogen with F. Okay, so if you look at the example that I have given you just now, HCl and HCl, do you have hydrogen bonding over here, Nathan? HCl and HCl, is it hydrogen bonding, Nathan?
No.
Okay, no, yeah, because it's not H with N, O, or F. Okay, now water and water is polar and polar, is permanent dipole bonding. Okay, so Catherine, do you think this is hydrogen bonding?
Yes.
Yes. Okay, this is hydrogen bonding. Okay, this is hydrogen bonding because why? It's the bonding between hydrogen and oxygen. Another example that I show you just now, which is going to be HF to HF. Okay, Sharon, do you think that this one is actually hydrogen bonding?
Yes.
Yes. Okay, this is yes. Okay, it's a hydrogen bonding. Can you give me another 2 molecules that can have hydrogen bonding? So I just mentioned to you just now, we actually have HF, okay, one of the molecule that can actually have hydrogen bonding. Water can have hydrogen bonding with another water molecule. Can we have other examples that can have hydrogen bonding? Frederick?
Ammonia.
Very good. Okay, ammonia. Nitrogen, hydrogen, hydrogen, hydrogen. Okay, this one is going to be delta negative, delta positive. So you have NH3, delta positive. Okay, delta negative, delta positive, delta positive. So if I actually put it here, delta positive with this, nitrogen and the hydrogen. Nitrogen with hydrogen. Okay, hydrogen with N, hydrogen with O, hydrogen with F, NOF. Okay, they will actually have, okay, hydrogen bonding. Okay, that is only one of it. How about another one? Can someone actually think outside of the box? Anything that you think that will possess or will have hydrogen bonding? Maybe in the past you have heard about it. Michelle, any other molecules that you think that might have hydrogen bonding?
Hydrogen and carbon.
Carbon, why? Definitely no. Okay, carbon and hydrogen, you can see that they don't have. Okay, one thing that I can give you, like for example, a clue. Okay, what is the clue that I can give? Something that can evaporate very fast. Even
OH.
yes, related to OH. So we are talking about what? Alcohol. Alcohol, okay, is another example of molecule that will actually have hydrogen bonding. Why? Just I put it as ROH. Okay, let's actually not debate on what is R. It can be any carbon numbers. Okay, ROH. So if you have ROH, I know that this is delta negative, this is delta positive. So if I have another ROH, delta positive, delta negative, what happens is this delta negative and, okay, let me change the pen. Okay, O and H, okay, they will have, okay, delta negative and delta positive, they will have hydrogen bonding over there. Okay, because it's the bonding between H and O. So alcohol is another type, okay, is another type of molecule that will have a very special type of permanent dipole-dipole, which is the hydrogen bonding. Okay, so we have, of course, we have other molecules, but I just teach you the common ones. Yeah, anything that can bond with oxygen and hydrogen, they will have hydrogen bonding. Okay, so that leaves us with one more. Done. So what is the big deal about van der Waals forces? Now, van der Waals forces, okay, is very interesting. Why? Because it applies to all molecules. Not only polar, okay, not only non-polar, it applies to all molecules. And compared to, okay, within the intermolecular forces of attraction, the ranking number 1 goes for hydrogen bonding. Hydrogen bonding is considered to be the kind of a very strong, okay, very strong within the intermolecular bonding, followed by permanent dipole-dipole. Now, the weakest among them is going to be your van der Waals forces. It's a very weak forces. Why? Imagine the remaining 2, they are permanent. Okay, they are permanent. So this one is a temporary bonding. Something that is temporary will not be strong. I told you earlier. Okay, it's a temporary bonding. Why we say temporary bonding? Let's actually have a look at Cl2. Let's say imagine Cl2 molecule. Now, electrons, they like to move around. Okay, they start to move around, they go hang around, say hi to each other, they move around. Okay, but at any point of time, if suddenly you take a camera, okay, I like to use this analogy. You take a camera, you snap a picture. Okay, imagine you can see the electrons and atoms and everything. You have a very advanced camera, for example. When you take the picture, at that point of time, there will be a possibilities of having a lot of electrons at one side compared to the electrons to the other side. Okay, there will be this kind of possibility because they are moving around. At that moment, when you took the picture, this is delta negative and this is delta positive. Okay. Now, there is a temporary dipole will come about. Okay, there is a temporary dipole will come about. Imagine there is another Cl2. What happens is electron is negatively charged. So what happens is those electrons, they will push all the electrons in this particular molecule because negative and negative repel. So they will push the electrons to go over here. And then less electrons will be here. So what it makes, okay, this particular molecule makes this situation. And this one will create delta positive and will create delta negative over there. And there will be some sort of a temporary bonding between delta negative and delta positive over here for that instant. Now, this is called van der Waals forces. And there is another long name for that. Okay, what is another long name for that? It's called temporary, okay, temporary induced dipole. Now, what is induced dipole? You see, because of the movement, okay, movement of electrons. So you have delta negative and delta positive. Temporary induced dipole, okay, and with another induced dipole. This dipole induces dipole in this molecule. So that's why they are called temporary induced dipole, or they, in other book, they call it instantaneous dipole, they call it instantaneous dipole, induced dipole. So whatever it is, okay, I do not care about the term. In your syllabus, okay, we take it as van der Waals forces. Okay, we take it as van der Waals forces. And do remember, this bonding only exists when you take the camera and you snap the image at that particular time. Let's say next time, what happens? The electron keep on moving. So the bond will be broken and there will be new bond will be, if you take the camera again, maybe there will be another bond that will be formed with the Cl. So do remember, this particular bond is not permanent. They keep on forming, break, form, and break. It's like having a relationship, okay, with another girl, and then the relationship is like on and off. Okay, then after that, not okay, okay, after that, not okay. So that's actually going to be, the bond is not going to be strong, okay. So if you compare with the hydrogen bonding, permanent dipole-dipole, van der Waals is the weakest intermolecular bonding because it is temporary. Okay, it's a temporary bonding. Okay, I think the best way to actually, if you want to write it in a long way, is supposed to be instantaneous. Okay, temporary instantaneous dipole, induced dipole. That's supposed to be the very good name for it. Okay, but I think it's quite long, and then a lot of students, I think even VAS EPR is quite long, yeah. So they try to make it easier for the students to understand. Therefore, they actually use this term, is a van der Waals forces. Now take note, van der Waals forces has different meaning when it goes to different syllabus. For our syllabus, we will take van der Waals forces for instantaneous dipole-induced dipole. Okay, this is according to CIE syllabus. Okay, in some other syllabus, they actually say van der Waals forces are hydrogen bonding, permanent dipole-dipole, and also instantaneous dipole-induced dipole in some other syllabus. Okay, so we focus on the CIE syllabus. Okay, CIE syllabus, van der Waals force is instantaneous dipole-induced dipole. Imagine camera or imagine on and off relationship. Okay, and it applies to all molecules. Okay, when it applies to all molecules means even HCl and HCl, they have van der Waals forces and they also have dipole-dipole. The strongest will be the one that is going to be prominent. Okay, the strongest is going to be prominent. So when we say boiling point or something like that, we are trying to break the strongest bond, which is the permanent dipole-dipole. Okay, but for some molecules, they only have, for example, Cl2 and Cl2, they only have the van der Waals forces only. So you just need to break this force only. So it means for non-polar molecules, they only have van der Waals forces of attraction.